So, section B, question 7, which does not involve the absorption of ultraviolet radiation or visible light. Blue appearance of copper 2 sulfate ions in daylight, that's true. Breakdown ozone up atmosphere, well that's free radical substitution, so that's true. The ionization of a molecule in mass spectrometer, that's false. That's electrospray. Remember ionization, electrospray / electron impact. It doesn't involve the absorption of ultraviolet light, visible light. And reaction between chlorine and methane at room temperature, that does involve it. Which statement about chloride ions is not correct? They form a white precipitate with silver nitrogen solution that's soluble in dilute aqueous ammonia, that's true. They form octahedral cobalt 2 complex with aqueous cobalt 2 ions or excess chloride ions, that's false. Question 9. What is the mole fraction of this much of MR of that dissolving that much? So first thing we can do is find out the moles. Moles is mass over MR, 100.0. Then find out the moles was dissolved in, mass over MR. And because we want the mole fraction, it's going to be the moles of 1 over 100, which is 0.01, divided by 30 divided by 50, which is 0.06. And that will give me 1.666 times by 10 to the power minus 2. And you know it's complicated. Do round it to 1 decimal place to, or 2 single figures to C or that, but you just leave it as B. So the correct answer is B. A 10 which has the electron configuration of a noble gas, H plus, no, O minus, O minus, no, Se 2 minus, yes. Which statement does not support the suggestion that unknown organic compound is? It's 1H NMR spectrum has 3 peaks, integration ratio of 2 through 3. That is true. It's certain to see NMR spectrum has 3 peaks. Nope, that's false. 1, 2, 3, 4 peaks. Which statement about inorganic ionic compounds is always correct? They dissolve in water to give neutral solutions. That's not always correct. They release energy when they melt. No, it's endothermic. Endothermic. They don't release energy when they melt. That's exothermic. They contain metal cations. Nope. Got ammonium. They form giant structures. Yes, that is always correct. It's ionic. And you should know from my ionic topic in bonding. Giant. Always about giant structures. Which species are lone pair of electrons on the central atom? It's going to be SO2, sulfur, and then it's got a lone pair of electrons. Whereas carbon dioxide does not have a lone pair of electrons. And which substance do covalent bonds break when it melts? Hexane, ice, iodine, silicon dioxide. Now, just think of your previous knowledge. Period 3 elements in oxide. You need to memorize that silicon dioxide has a macromolecular structure. Actually, you don't even need to know that. Silicon dioxide has strong covalent bonds. That's what you need to know. So obviously, it's the covalent bonds that break when it melts. And which molecule are all the atoms in the same plane? Well, if you look at CH3CHO, CH3 C-double-bond CH. Definitely not in the same plane, because you can draw them as wedges and all of that. CH3 NH2, CH3 NH2, nitrogen has lone pair of electrons. I mean, again, not flat molecule, not in the same plane. Whereas C6H5Cl, okay, let's draw like this. It's got a Cl group here. That's in the same plane. Whereas D, C6H5 CH3, well, the CH3 can be written as C, H, H, and the bonds as well, so it can't be D, it is C. Which molecule has a permanent dipole? Okay, so we're looking for the one that is unsymmetrical, not symmetrical. BF3 is symmetrical, so dipole is going to cancel out. They're all pulling away from each other. It's not an A. NH3, well, what do we know about NH3? NH3 is not going to have the same structure as BH3. Why? BF3. Why? Because it's got a lone pair of electrons. It can form NH4 plus ion, ammonium. So that's not completely symmetrical, is it? Plus the lone pair of electrons. So therefore it's going to be NH3. CiCl4, that's completely symmetrical. SO3, same with BF3, completely symmetrical. Which statement about this is correct? Well, what's this? Carboxylic acid, right? COOH group. And can it form a hydrogen bond? Yes, it can. The COOH, the hydrogen bonding with electron deficient H atom can form a bond with NOF atom, nitrogen, oxygen, fluorine. So this H can form a hydrogen bond. So therefore that must be correct, and you don't really need to go through the rest because that's correct. A mixture of 2 dm³ of hydrogen, 1 dm³ of oxygen at room temperature, which statement is correct? Definitely not D, because if the partial pressure of each gas is the same, you'd have the same volumes, which they don't. There's no reaction to form water because molecules do not collide with sufficient energy. That is correct. Molecules do not collide with sufficient frequency. No. 19. Which statement about distribution curve of molecular energies? That D or gas. I give you temperature is correct. There are no molecules with zero energy. I just know that off by heart from the Maxwell-Boltzmann curve. You should as well, so that's an easy mark. Which statement about the addition of a catalyst to an equilibrium mixture is correct? This one is, in my opinion, very tricky. The activation energy for the reverse action increases. That's clearly false. We can get that out of the way. If anything, it would decrease it. But it doesn't, because the rate of forward and reverse reactions happen equally. The equilibrium constant for the forward reaction increases. But that's a catalyst. And how can a catalyst affect equilibrium constant? A constant? No. Only temperature. This key fact, and you just need to keep reviewing the topics. Only temperature can affect the value of Kc. Not a catalyst. So it can't be B as well. So now we're left with C and D. The rate of the reverse reaction increases. That is true. That is true. The rate of the reverse reaction and forward reaction increases. The rate of the reverse reaction increases. Yeah, that's true. Because that what will happen? The enthalpy change for the forward reaction decreases. No. Hess's law. Enthalpy change is independent of the route taken. So it's not D as well. So therefore the answer is C. This one, which equation does not show the reduction of transition metal? These type of questions, they like to ask these type of questions, and always look at oxidation states. If you do that, you should be pretty good with these questions. So obviously, as long as you calculate oxidation states correctly. So TiCl4 oxidation state of Ti is +4 to 0. Well, that is clearly being reduced. So it's not A. It says does not show the reduction. So we're looking for one that does not decrease in oxidation state. 2Fe-Cl3. Remember, when we calculate oxidation state, we don't care about these moles. So Cl3 minus 3, so that's plus 3. Cl2 minus 2, so that's going to be plus 2. That's being reduced as well. MnO2, well, that's plus 2. Oxygen's minus, no, it's not plus 2, it's plus 4. Oxygen's minus 2 times 2 minus 4, so you need plus 4 to get overall charge of 0 for the compound. MnCl2, that's plus 2. So that's also being reduced, therefore the answer must be D. And if we look at D, well, oxygen is minus 2, so that's plus 2. Well, in this case, the overall charge is minus 2. Chlorine in group 7, so that's minus 1. Minus 1 times 4, minus 4. And therefore, to get an overall charge of minus 2, it needs to be a plus 2. So therefore, the oxidation state does not change. So if we're going from CO in plus 2, and then CO in plus 2, with a plus 2 oxidation state, so therefore it's not being reduced. But the answer is D. That does not show the reduction of transition metal. 22, which substance contains delocalized electrons? This is a nice one. Graphite. Need to know. Usually when they ask about substances and structures, it's usually substances you've covered before in the specification, so you should know them off by heart anyway. And obviously if you are struggling, well then it means you probably don't know it generally, but sometimes it might involve some weird substances. But in this case, graphite, yeah, you study that in bonding. Iodine, you also go through that. Sodium chloride, you also go through that as well. Cyclohexane, we don't look at the exact structure and learn key details about it. Cyclohexane, not really. But obviously it's not going to have delocalized electrons. 23, which compound has Ez isomers? Well, in order for that to happen, each carbon has to have each carbon has to have 2 different groups. Okay, that's a fact. So if we look at A, no, because these two are the same. Each carbon has to have 2 different groups. Not, okay, that's a H and that's a Br, so that's fine. But we've got 2 of the same groups here, so it can't be A. Look at B. Definitely not B, you can already tell, because both carbons have the same groups. Both carbons have 2 of the same groups. HH in the left hand side and BR on the right hand side. Look at C, C11C, HBr, HBr. Yes, it is C. It has Ez isomers. And I'm thinking, maybe you guys hopefully aren't thinking that, but they are the same, Iman. Yes, but you can still form Ez isomers because it said, what I wrote down before when I started this question, each carbon has to have 2 different groups. They do. These 2 carbons have 2 different groups. This case has a hydrogen and a bromo, H and a Br, and a H and a Br. The different, whereas A, B, they both had the same. Like in this, B it had HH, Br, Br. A had HH, HBr. And D, well, it's got Br, Br, HBr. And well, these 2 are the same, so it's not going to have Ez isomer. Therefore, the answer is C, since each carbon has 2 different groups. 24, which polymer has hydrogen bonding between polymer chain? This is another thing you need to memorize. It's Kevlar. This is definitely a repeat question, I'm pretty sure. Gone through this. I don't know if it's last year's multiple choice, paper 3, A level, was the year before that, I don't know, but I remember this question. Gone through this before. Which compound is the greatest amount of oxygen for the complete combustion of 1 mole of compound? Complete combustion, so adding oxygen to form CO2 plus H12. Now this is not a typical question about this. It's interlinking the complete combustion and the structures, right? So it's a bit more complicated. Well, we've got ethanol aldehyde, CH3 COH, ethanol CH3 CH2OH, ethane 1,2-diol, and methanol. Well, these both have plenty full of oxygen. They both got loads of oxygen compared to A and B. So they're not going to need the greatest amount of oxygen because they have a lot. So you're not going to need a lot of this oxygen. Now we're left with ethanol and ethanol, A and B, A or B. Well, let's think about it. We've got CH3COH and we've got CH3CH2OH. Well, that's got CH3CH2OH. Well, that's got an extra 2 hydrogens. So it's going to be B, because it's going to need more oxygen for those extra 2 hydrogens. 26, which compounds produce when one phenyl ethanol reacts with acidified potassium dichromate. 6. Well, that's which compound produce reacts with that. It's going to be this one. We'll draw it out. We've got the carbon's in its correct place to form the bond, so it's going to be C. Which is the correct general formula for non-cyclic compounds in the homologous series? Well, what is alcohol? Alcohol is CnH2n plus 1 OH. That's a classic example, right, for its general formula. That's the exact same. All they've done is they've just put this hydrogen here, so it's CnH2n plus 2 hydrogens. CnH2n plus 2. Oh, because this is for non-cyclic compounds. This is for cycling with non-cyclic compounds, so therefore it's A. 28, which compound forms a white precipitate when added to aqueous silver nitrate? Well, we're looking for the one with chloride ions. Therefore the answer is going to be D, ethanol chloride. Nitration of methyl benzoate produces methyl 3-nitrobenzoate. Percentage yields that one massive methyl 3-nitrobenzoate is produced. Find out the moles of methyl benzoate, so it's going to be 0.0125. How do I work that out? Mass over ml 1.70 divided by 136.0. 1-to-1 molar ratio. So for the moles of methyl 3-nitrobenzoate is that moles is mass over ml. Mass is going to be 0.0125 times by the ml of methyl 3-nitrobenzoate, which it gives us in the question 181.0. If it didn't give you the mLs in the question, that I feel like that would be ridiculous for one marker, and you have to also find out the ml. I just feel like that's really harsh. But yeah, they give you the ml, then you get the mass. But also remember the percentage yield is 65%. Why would they give you the percentage yield? There's a reason to give you that, because now you need to times your answer with 0.0125 times by 181.0 times it by 65 divided by 100. Always do that when it's percentage yield. So if it said the percentage yield is 85%, let's say for example, well then I'll times it by 85 over 100. Yeah, so if it gives you the percentage yield, think why would it give me the percentage yield? So we need to times it by the percentage yield, 65 over 100, and we'll get 1.47. A two-step preparation of propyl amine is shown. Was X? Well, X is going to be the one with a cyanide group, Cn. And if you look, it's not A that's got an amide group. It's going to be B. It's got a Cn group. Which compound reacts with warm dilute aqueous sodium hydroxide? Well, that's benzene. Benzene is not going to react with warm dilute aqueous sodium hydroxide. It's too strong. It's, firstly it needs electrophile, it needs AlCl3, and it only forms electrophilic substitution on that, and it's not going to form nucleophilic substitution. Then you've got this alkene. Well, the alkene isn't going to react with that, no chance. Then you've got your amine. Well, that's also not going to react with that. So you're left with this ethanoic anhydride, which will react with it. It's not got no double bonds or anything. And will bond with it, react with it. Which is not a possible product of this reaction? Well, these two, we can cancel out these two. These are two definitely going to be possible products of this reaction. So we're left with C and D. And a lot of students would be like, both of them on because they've got minus and plus charges. Well, they're obviously going to cancel out. But if you think about it, what's the difference between these two, C and D? C2H5 2, C2H5 3, and CH3. Well, then this nitrogen is perfectly where it's supposed to be. It's not where it's supposed to be. Therefore, it's not going to be a possible product of this reaction, whereas this one is where it's supposed to be. The 33, which is a repeating unit of a polyamide. Polyamide. Amide, NH2, right? Poly. We want C1 with two NH2 groups. Not A, not B, not C, and it is D. NH, NH. No, sorry, not two NA. H2, it's got NH and your NH. So NH, NH. So two NHs. And that is a correct repeating unit of that. Which type of polymer is not hydrolyzed by heating with concentrated aqueous sodium hydroxide? Polyamide is hydrolyzed. Polyester is hydrolyzed. This is protein or polyalkene. The answer is polyalkene. And just think about, have you recognized this when you've gone through in class? Yes, I have. Have I recognized this? Polyalkene. I've never heard that before. Polyalkene. No. Which is the structure of a zwitter ion of an amino acid? Zwitter ion, so it's going to want to have positive and a negative charge. This is when you need to know your definitions, and I still haven't memorized the definition of this, but I'm working on it. And it also, therefore, it's positive and negative. It's only going to have two charges, right? So we can already eliminate A because that's got 1, 2, 3 charges, and we can also eliminate B because that's got 1, 2, and 3 charges. Now we're left with C and D. Well, the thing about the difference between C and D is that in C, the R group, the alkyl group, has an OH2 with an oxygen positive charge. In reality, it's not supposed to be like that. The positive charge is meant to be here. Therefore, the answer is D. This is wrong because it has a charge on your R group. You're not supposed to have that. And therefore, that's correct. Structure of a zwitterion of an amino acid. Which row shows a pair of bases that can link two strands of DNA with 3 hydrogen bonds? Use the data booklet to help you answer this question. Look at the data booklet, look what pair of bases link 2 strands, 3 hydrogen bonds, and you should get cytosine and guanine. So therefore the answer is C.